Okay, 8.1 is a lot of review. Most of it's review from things that you've done before, but there's just a baby section at the end that is new. So we are going to review first all your exponent rules, okay? So I have this chart that you've probably seen before, but I'm going to go through them pretty quick. So the first property that you have of exponents is when you multiply things with a common base, you add the exponent. So this example right here would really be 3 to the 1/2 plus 1/2. And when you add fractions, you can either use your calculator or you remember the denominators have to be the same and you add the tops. So this is 3 to the 2 over 2, which is just 3 to the first or 3. Okay, so that's your first rule. When you multiply, you add. Okay, second rule, when you divide, you subtract. Okay, bases are the same, so these both have a base v. So this is really v to the 1/2 minus 3/2. You can use your calculator again, or you know that you go 1 minus 3 is -2, so it's -2 pieces of size 2, which is v to the -1, which later on you'll learn what the negative does, or you'll be reminded of what the negative does, but that's the second rule, division. Okay, third rule that you have is when you have a power to a power. So power to a power means we're going to multiply. So we have n to the 3/2 times 1/2, and when we multiply fractions, we multiply straight across. So this is really n to the 3 times 1, which is 3, and 2 times 2 is 4. So that would be your final answer on that one. Okay, so we've done multiplying, division, and then we have power to a power. Next rule that comes in handy is you're going to see a lot of fractions. So when we have fractions raised to a power, that means we distribute this to both the top and the bottom, and it's still multiplication. So this is a couple things. We have x to the 1/2 times 3/2 on top, and x to the 1/2 times 3/2 on bottom. Okay, then we multiply. When we multiply fractions, it's straight across. So this is x to the 1 times 3 is 3, and 2 times 2 is 4. And on bottom, you'd get x to the 1 times 3 is 3, 2 times 2 is 4. And then look, we have division, which is subtraction. So this is really x to the 3/4 minus 3/4, which is x to the 0, which you'll learn down towards the bottom that really equals 1. But the main idea here is that when you have a fraction raised to a power, the power distributes to the bottom and the top. Okay. The next rule that should be familiar is what negative exponents. Okay. Negative exponents, okay, changes location. So if it's negative on bottom, it moves to the top. And if it's negative on top, it moves to the bottom. Okay, so for the example that they have, if you have x to the -1/2, that's the same thing as 1 over x to the 1/2. And if you have like 1 over x to the -7, that's the same thing as x to the 7th power on top. Okay, these last rules are just minor rules. Anything to the 0 power is 1. Remember that. Okay, and then this one you learned last year. If you have fraction exponents, okay, this is how I remind all my students. If you have a fraction exponent, power on top, root on bottom, because if you have power, you are on top, and if you have roots, you grow in the ground, so you're going to be in the bottom, okay? You're going to need to remember those for the first half of your assignment, okay? The back side of your assignment, though, is the new part. And this is where we're going to solve things by making the bases the same. And this is my Megan trainer coming in. You have to remember that everything revolves around the base. Okay, so it's all about the base. So here's what we're going to do. You need to know your powers and what perfect squares are. Okay, so we are going to try to get this. The best way I can explain it is this. If you go back to when you were little and you had like 2 to the star equals 2 to the 3rd. You could say, oh, if my bases are the same, then my exponents also have to be the same. So you'd be like, oh, star equals 3. That's the goal of what we're doing right here, okay? We need to make the bases the same. You cannot ever make your bases bigger, but you can always make them smaller, okay? So in this example 1, I'm going to zoom in. Okay, example 1, we have to go with 2 being our base. So we're going to try to make this 2, this 4 into a 2. So the way I do that is I know that 2 squared is the same thing as 4, and I'm going to raise it to the x power. Okay, then I know a power to a power means multiplication. So this is really 2 to the 2x equals 2 to the third. This is awesome because my bases are the same, and once my bases are the same, then I know my exponents are the same. So I know 2x equals 3, and then I solve that equation. Divide by 2, divide by 2, x equals 3/2. Okay, pretty straightforward. Next example, I'm going to run through this one real quick. We cannot make them smaller. We cannot make them bigger. We can only make them smaller. However, I can't say that 9 to some power is 27. So I'm going to have to change both of these. These are both powers of 3. So 9 is 3 squared to the 2x, and 27 is 3 cubed to the x minus 1. Powers to power mean we multiply them. So this is 3 to the 2 times 2 is 4x equals 3 to the 3 times x minus 1. Well, I'm going to have to distribute that. So when I distribute, I get 3 times x is 3x, and 3 times negative 3 is negative 3. Bases are the same, so my powers are the same, so I'm going to get 4x equals 3x minus 3. And then I solve using basic algebra skills. I do minus 3x, and I get x equals negative 3. Cool? Okay. Problem number 3. This one, it looks a little bit different and it looks tricky, but the idea is still the same. I'm trying to make them so they have the same base. This probably makes everybody really uncomfortable. But the cool thing is I have a rule that can make something from the bottom move to the top. So I can really keep this side the same, but this is 2 to the negative 1. If I give it to the negative 1 exponent, it makes it come to the top. Okay, and now I know that my base, I have to go smaller, so I'm going to change this into a 2. And if I go 2 times 2 is 4, times 2 is 8. So this is 2 cubed to the 2x equals 2 to the negative 1. When I have powers to power, I multiply. So this is 2 to the 6x equals 2 to the negative 1. Bases are the same, so 6x equals negative 1. Divide by 6, and I get x equals negative 1/6. Same idea. As long as I can rely back on those rules in the chart above, this is really, really basic. The more you do of them, I promise you, the easier you're going to recognize the patterns and what rule will make this work easiest for you. Okay, good luck. Let me know if you have any questions.